In this video, we're going over a palindrome linked list. So given the head of a singly linked list, return true if it's a palindrome. In our first list, or in our first example, we're given 1, 2, 2, 1, and if we reverse the ordering of the nodes, we get 1, 2, 2, 1, so it's the same. So we can return true. Now let's go over the dot process. Let's first go over the definition of a palindrome. A palindrome is a word that can be read the same way forwards and backwards. We are given a singly linked list. We can reverse the ordering of the nodes in the upper half of the list. Then we can compare the reverse upper half with the lower half. So in our first example, we're given 1, 2, 2, 1. If we reverse the nodes here, 2 and 1 into 1 and 2, we can see that it matches the lower half. Now, how can we reverse the upper half? We will need to find the upper mid node. So in this case, the upper mid node is located here at 2. Now, how can we find the upper mid node? We can implement a two-pointer approach. We will have 2 pointers, slow and fast. The fast pointer moves 2 steps at a time, and the slow pointer moves 1 step at a time. When the fast pointer reaches the end of the list, then the slow pointer will reach the center of the list, or the mid node. This will allow us to reverse the list starting from the slow pointer. Now let's go over the pseudocode. So let's validate the input parameter. So if head or head.next is equal to null, this means it is a valid palindrome, so we can return true. Now we want to find the upper mid node. So find the upper mid node. So we're going to have 2 pointers. So we're going to create 2 variables. Slow moves 1 step at a time, initially at the head node, and then fast moves 2 steps at a time. It will also be initially head. Now while fast and fast.next is not equal to null, we can move it 2 steps. Set fast to fast.next, and then once set slow or fast.next.next, move it 2 steps, and set slow to slow.next, move it 1 step. Now if fast is not equal to null, if fast is not equal to null, it's currently if fast is equal to null. So let's see here. If we currently starting at the head node, and if the fast node moves 2 steps, 1, 2, it's going to be null. And then our slow pointer move 1 step, it's going to be 2 here. So it isn't a valid upper mid node. But what if there's an odd number or odd even nodes? So what if there's only 3 nodes? So currently, let's ignore this node here. Let's currently focus on 1, 2, and 2. And if the fast pointer moves 2 steps, it will get to this node, and then the slow pointer will move to this node here. But we want the upper mid node, so we actually want to get to the upper half of the list. So we actually want to reach this step here. So if fast is not equal to null, we're going to set slow to slow.next. This will allow us to reach the upper half. Now, we can then reverse the ordering of the upper half, starting from slow. And then we'll say the head of the reverse list to be reversed. Now we want to compare the two lists. So while head and reverse is not equal to null, if head.val is not equal to reverse.val, we can return false. This means it's not a valid palindrome. Then we're going to set head to head.next. I want to set reverse to reverse.next. If the lower half and the upper half are the same, we can return true. It's a valid palindrome. Now let's go over the time and space complexity. For time complexity, we get O of n plus O of n. Actually, we can say O of n divided by 2 plus O of n divided by 2 plus O of n divided by 2. So it's equal to O of n, where n is the number of nodes. So initially we have finding the upper mid node. Then we have reverse the upper list. And lastly, we will check if lower and upper lists are the same. And reverse upper lists are the same. In our space complexity, we get O of 1. Now let's go over the code. So we'll first validate the input parameter. We will have if head is equal to null or head.next is equal to null. This means it's a valid palindrome. We can return true. Now I want to find the node that's currently in the upper half. So I want to get upper mid node. Then I want to reverse the ordering of the upper mid. So we can say reverse node. Now let's create these methods first. We will first get the upper mid node. We're going to create two pointers. Slow is equal to head and fast is equal to head. Then while fast and it's not equal to null, and fast.next is not equal to null. Want to move fast 2 steps, and want to move slow 1 step. Now if fast is not equal to null, we're currently in the odd list or odd number of nodes. We want to move our slow pointer forward to reach the upper half of the list. So I want to return slow.next. Else we can just return slow because we're currently at even number of nodes. If we have even number of nodes, the slow pointer will already be in the upper half. Now I want to reverse the ordering of the upper half. We're going to create a variable reverse to keep track of the head of the reverse list, initially null. Now while head is not equal to null, want to keep track of the next node first before we disconnect the current node. So I want to set head.next. Then we're going to set head.next to reverse. Then we can update the head of the reverse list. Then we can move forward to the next node. Then we can return the head of the reverse list. Now we have reversed the upper list. Now we just need to compare the lower half with the upper half. So while head is not equal to null and reverse is not equal to null, if head.val is not equal to reverse.val, this means it's not a valid palindrome. We can just return false. Want to move head forwards and want to move reverse forward. We'll return true if the lower half is equal to the reverse upper half. Let me know if any questions in the comment section below.